Thanks for coming here. Guess we are up to start. My name is Leo, and I'm a senior product manager in Coinbase, part of the security platform engineering team. We're the team in the company that build the platforms that protect our customer funds. And I'm going to talk to you a little bit how we use MPC cryptography to protect our customer funds. And I hope that's an interesting session. Let's see here. Okay, so what's the challenge we're talking about? As our CEO recently posted, if Coinbase were a bank, we'd probably be around the 20th largest bank in the US in terms of assets that we hold. Now, I like the bank analogy, but if you think what a bank really is, it's basically a big ledger that has entries for assets around the world like bonds and loans and gold. Whereas in crypto, what we're holding is the actual asset itself. So for me, it's better to say like we're closer to Fort Knox than to a bank. We're actually protecting the digital gold. On top of that, blockchains are irreversible. As you know, if you lose something, it's gone forever. It does make us a major target. And as we're seeing, adversaries are getting increasingly more sophisticated, more investing very high amounts of talent and money to try to break into crypto companies. And trust is very central to our brand. It's one of our big motors. So we go above and beyond to protect these assets. All right, so if you're faced with that challenge, what's the kind of solution you look at? You have all the different technologies you can think of, HSM, servers, data centers, 2FA, YubiKeys, and so on. You have all the hard choices between vendors, and single vendor can become a point of compromise. You have to worry about supply chain attacks and so on. Different use cases with different needs that will have competing requirements, and all these difficult trade-offs in the security world where if you make something too easy to use, you make it less secure. Now, while thinking about this, we were asking ourselves, why not make everything available? Every technology that has a good use, that has value, should be made available to our customers, to our internal customers, our client teams, but without forcing anybody to use anything that they don't want. And I'm going to talk a little bit how we achieve this. Little recap here. When talking about key management in a crypto company, the KMS has two jobs. One, protect the keys, private keys, wallet keys, both at rest and at use. And second, sign crypto transactions in a secure way when demanded. A very, very simplified transaction flow would look something like this. You have a customer somewhere that's interacting with a Coinbase system. That could be retail, institutional, advanced trade, self-custodial, all the kinds of things. That system requests for a transaction that goes through a wallet layer. That wallet layer is responsible for actually creating the transaction itself, put addresses, values, tokens, and so on. That transaction is sent to the KMS to be signed, which is then broadcast to the blockchain. So it's a very simplified view where we sit on the tech stack. Second recap here, MPC, Multi-Party Computation. That's a cryptography technique which allows you to compute a function, and that could be literally any function, between different parties, different entities, where those entities give their inputs, but they preserve their inputs. The inputs are not revealed during the computation. So if you translate that to the crypto world, we're talking about here is usually taking a private key, splitting into shares, so-called key shares. Every entity holds a key share, and to sign a transaction, to create a transaction signature, you run an MPC protocol where every entity collaborates with their own key share without revealing them. So the key shares never leave the entity itself, or the party. And very importantly, if you obtain, in this example here, we have 3 parties. If you obtain 1 or 2 key shares here, you have 0 knowledge of the key. So that's a very powerful concept that allows you to work in a way that is literally no single point of compromise. And more importantly, the private key never exists during this process. So you do sign transactions without ever recovering the key anywhere. Okay, so we have what we call the MPC engine or MPC core, and we built the system on top of that. Why are we doing this? Those are the principles we followed. Obviously, secured above everything. We want the customers to be secure. Consolidation. So Coinbase is growing a lot in the last 10 years. Obviously, that creates an environment where there's a lot of legacy technologies that were created for in the past for specific use cases. One key thing here is like we wanted a system that could care for all current use cases and all future use cases, which means it needs to be expandable. Efficiency, everybody has limited resources. You need to make good use of those resources to, again, increase the security of your system. Flexibility is the key innovation here. I'm going to talk a lot about flexibility, how you can configure different capabilities for different use cases, and that's the core of our proposal. Speed, best in class for every use case. That could mean very fast wallets for retail or some friction for institutional customers, whatever is best for that given use case. And last but not least, we're always looking to enable the business to perform and to do what the business needs to do in terms of SLAs, compliance. Regulation is a big topic for this year. Localization as well. There's a lot of demand for funds to be localized and all the custodial modes, self-custodial, custodial, non-custodial, and so on. Okay, so again, customization here is the key. The whole idea is when you have these, basically what is a distributed system where there is no single point of compromise, we have key shares spread across different, as we like to call them, capabilities. You can freely combine those capabilities in the best way for your own purposes. You don't have to demand that all entities, all parties participate. You can pick and choose for your portfolio, maybe even for a single key. And most importantly, the crypto wallets, the private keys, they get properties according to which capability you're choosing. For example, if you choose everything that sits in the US, that also gives that key the property of being under the US jurisdiction. If you choose things that are sitting in Europe, if you choose servers and data centers that are in Europe, that also gives that key the properties of being under MiCA and under European regulation. And by default, you kind of get a tech diversification as long as some of these capabilities are implemented in different clouds and different devices and so on. Okay, I'll walk us through an illustrative example. That's not exactly the setup we have. That's an example where it can be achieved, but it's not that far as well. So imagine you have a system deployed like this. Again, it's a distributed system. Each entity there is an independent entity that participates in the MPC protocol, hold key shares. You start with some cloud servers. It could be in different parts of the world, US, Europe, Asia. You can also use different clouds, GCP, Azure, and so on. Then you can have some physical data centers of your own spread across the world again, and that gives those wallets that property of physical protection, right? An attacker would need to break into a place, not only break into an online server to be able to access something. You can obviously involve some AI agents that do some clever analysis and real-time blockchain fraud detection kind of thing. You can involve company employees, and we are a remote company, so we get that geographic distribution of secrets, make it even harder for an attacker to find secrets that they can break into. You can involve some security personnel and demand that security people actually look at transactions and click a button and participate in the signing process itself, create basically a manual process, and ultimately you can even involve the customers themselves in protecting those assets. Okay, let's say you have that set up, and I enable my client teams to come and choose what they want. Let's say there's a client team, retail side, that come to us and say, hey, all I need is a hotkey. So let's use the 2 online servers you have, no manual interventions, no data center. It's based on both EU and US, and that gives you this very fast performatic key that can sign millions of transactions a minute, and you're good to go. Now, a different team could come and say, I want to use one online server and the customer themselves. Of course, the customer here means either a mobile device or a desktop. And since you're sharing between Coinbase and the customer, you give that key the property of being self-custodial. So we, Coinbase, cannot sign by ourselves if the customer do not collaborate. Then let's say you choose a manual key here, more specifically a US manual key. You take online servers in the US, data centers in the US, some AI for extra protection, but you also give a security person a device that they need to look at, click a button to proceed with the transaction. It creates basically this very manual, high security key. And obviously, you can get creative, use everything you get for maximum protection, create a so-called vault key, and use that for very sensitive portfolios. And even if you look at that, you can get even better if you manage to involve the customers themselves in that protection. Now, on the previous slide, you saw if you think about all those funds we hold, billions of dollars in digital assets, they were spread across those 7 entities there, right? You would need to break into 7 different places. Now, once you start involving the customer themselves, all of a sudden, instead of 7 places you would need to break into, you have hundreds, maybe thousands, because if every customer participates in protecting their own funds, even if an attacker gets control of all of Coinbase infrastructure and capabilities, you still cannot do anything if the customer doesn't participate. So this is a really powerful concept that we have. If the customer holds an actual key share, cryptographic key share that we cannot sign a transaction without the customer participating, that increases both security and usability in a very big way. Okay, regulation, that's, again, a big topic for us. So if you imagine there are regulators everywhere that are demanding more and more of local controls. One way we achieve this is if you deploy something locally, let's say for Brazil there, and give the control of that entity to the local Brazilian entity of Coinbase, that means that entity has the power to stop transactions for the Brazilian users if they want to. And that's something regulators are really concerned about. It gives that local control, but preserves the global security that we have in the whole system. So key protection at rest, that's clear, but what about key protection at use, right? So the way we achieve this, using the distributed concept, is we have these policies which are encoded and signed and pushed to the edges. So every single entity in the system independently verify the policies, things like destination addresses, maximum values, and time of day, rate limiting, that kind of thing. Every entity verified policies independently, which means there is no single server that you can break into and change a policy. So it gives the same type of protection you have for keys at rest to the use of the keys. Okay, I like this chart a lot. So we all, in the security space, you all, always facing this trade-off, how secure and how usable or fast or whatever interpretation of usability you have. And as I said, we came from a scenario where we have these different technologies, fragmentation, different systems for different use cases. What that creates, it's not only this fragmentation you can see, but also it kind of creates this boundary, and that's related to, again, the use of resources. If you fragment your resources and you invest in different systems that not everybody can use, you basically create this boundary. If you unify those resources in a single system and everything you build to that system is available to the whole, to all your clients, first thing you get is you push that boundary way forward, right? Because you're making a much better use of what you have. And second, the same system can go through any of the combinations there. So you're free to choose where you want to be on that curve, and that creates that ideal scenario where you consolidate everything and we expand both security and usability for everybody. Okay, last but not least, as of last week, we have open sourced our MPC library, so the MPC engine I talked about that powered the system. It's now available online. That's pretty recent, so we're inviting everybody to take a look and give us feedback, use the library, feel free to test it. And the last message, we have a booth here in the forum. We have a lot of roles open on the security space. If you're interested, come have a chat with us. And thank you. We can open for questions.
Yes, thank you very much for this presentation. I just have a question about the role of the user. When you explain that we need to have him more involved, maybe in the process, can you just tell us more about this? Yeah. And maybe the risk in terms of security and stuff like this?
Yeah, so an interesting thing, a fact that you got in this type of system is when you add a new entity, right? You have, as I show, you have 7 entities in company. If you add an extra entity, because of the properties of MPC, there is no way you can detract from security, right? You cannot remove security from the system. Because again, every entity is independent, do policy checks independently, and have their own properties and protection. When you add something, it's very hard to get a scenario where you decrease security. When you involve the customer, of course you need to give something that the customer can use to perform, like whether that's a mobile app or a laptop or an HSM, and the code that they need to run locally. We can talk about scenarios where the customer is an institution, have a server on their side that collaborates here, or you can have a user with a phone that holds a key share and click. In both cases, there is no way, even if that device is stolen or the customer doesn't take good care of the key share, that doesn't change the properties, or that doesn't detract from the security of the system itself, because they are independent. Even if you break into, again, if you break into any of those entities, it doesn't affect the others. So if you're adding a new entity, like the customer, and somebody breaks into the customer, steals that key share, it gives them zero value, zero knowledge of the key. And the way we involve the customer is, yes, we have in some cases apps, we have in some cases servers. We don't do this for every retail customer, because that'll be a challenge, but in terms of institutional customers, they're usually involved. It doesn't have to mean it's self-custodial, right? We're not telling the customer you are protecting your own key. No, we're just giving them a device and some secrets, and we tell them you need these secrets to sign, and that's it. And we can internally recover the key if that's needed. So it's still full custodial solution, unless we choose to be self-custodial, as I showed in the other example. Did that answer the question?
Hi. Can you talk about a bit this about the recovery path? So, like, if someone has a key share, loses his key share, what is the process to refresh the key share and have access to another key? And how do you see this process? Do you have a process that would keep the non-custodial property of the whole deployment?
Yeah. So, for the self-custodial or the non-custodial scenarios, there needs to be a really good understanding on the customer side that they need to keep the backups, right? If you imagine, like, if you have one, let's simplify, you have two key shares, one on the customer, one on Coinbase. What gives the property ultimately of the custodial mode is whether we are holding the backups or they are holding the backups. And just for information, like, the backups are also split, and you need multiple parties to collaborate to restore a key, but it's a separate set of entities. There's more humans in the loop. You need a process to recover keys from backups. But if we have the power if we hold the backups and we have the power to recover those keys, then that's a considered custodial solution. If we can even hold the backups, but give the customers the encryption keys, and that creates this self-custodial mode. So it's basically, in the case where we share with the customers, it's a matter of who can recover the key in the case there is in a DR scenario, ultimately.
Thank you.
Well, thank you for the presentation. It was clear. I was actually interested, what is your approach, or at least Coinbase approach, regarding user security whenever they want to interact with the external protocol, like, for instance, with DeFi protocols? Is there a filtering limitation for institutional players so they can, be protected against potential scams or fake websites?
Yeah, so I'm not exactly on that layer, on that product, but I can tell you we do have different solutions. So on the institutional side, for example, we have fully custodial solutions, which is more limited in terms of what you can do, what verbs you can execute, that kind of thing. But we also have self-custodial solutions where I would need to double check, but I think the institutional player would be able to sign anything and interact with any protocols. I know we have different solutions with different levels of access. But I'm not on the details on that.
Okay, perfect. More permissive, depending on the use case. Well,
Yes,
that's pretty clear.
exactly.
Thank you.
And from the key management side, we are agnostic, right? We sign a transaction. As long as the policy holds, it's fine for the key management to sign.
Thank you for the presentation. Two questions. First, do you use any HSM at all? Would it be a MPC over HSM? And second question, don't you have any performance limitation regarding the use of MPC, like a signature per second limitation?
Yep. Oh, great question. So, is there any Ubiquitous guys on the room? So we were talking about, I actually had a chat with Ubiquitous yesterday. So the MPC protocol itself, we can't run them inside the HSMs, right? So we try to push the protocol to as much as possible inside the secure environment. So we're looking at AWS Nitro, for example, for the server side. We do use HSMs in general to protect secrets, but as I said, the HSM itself doesn't run the protocol. But we are looking at Nitro, maybe pushing some code inside a Ubiquitous HSM, secure enclaves and TEEs, in order to give that, the secure memory protection to the protocol itself. But in general, since the HSMs cannot run the protocol, we need to extract the key share to a local memory, run the protocol, and push it back. And there are some cases, where the protocol itself, so we have a world-class team of cryptographers. In some cases, the protocol can be simplified in a way that, for example, when a customer is involved, the operation you can tune the protocol in a way that the operation not on the customer side or on the human side becomes as simple as decryption that the HSM can perform. So you can tune the protocol itself in a way that some operations can be done by standard decryption or signing. But in general, yeah, we have to pull the secret to memory, execute, and go back. We're working towards pushing more and more code to secure environments over time. And the Ubiquitous talk yesterday, I was asking them, can we push some MPC code inside the HSM, basically.
And what about the performance?
Oh, performance. So the protocol itself, it's very high performance. It's nothing fancy. It's mathematical equations that are running in a CPU. What determines performance ultimately is the network. So if those entities are spread across the world, in some cases, if you have humans involved that are using mobile devices over 5G, then the performance degrades, right? So it's about which entities, it's about network latency between the entities. You can do as fast as one internet connection. If you have just, for example, if you have just an online server and the customer, that's as fast as the customer can connect to the server. When you talk about an MPC would be, depend on the my cryptographers will probably correct me, but between 2 and 8 messages, round trips. So that's basically is the performance. We have deployments where the sign itself is 50, 100 milliseconds. We have deployments where it takes a minute, again, because of all the hoops you need to go through and but it's all about network latency.